in the steam sterilization area. Same air pressure, same cycles as the prep and pack area is concerned. So, as you recall from our lectures, we have several different types of steam sterilizers. Gravity air displacement sterilizers, usually the domain of tabletop sterilizers, okay? And dynamic air displacement sterilizers. Gravity air displacement uses expanding steam to push out the residual air, while dynamic air displacement machines such as these guys right over here, okay, use a vacuum cycle to pump the air out of the chamber. So we start off with a vacuum. These are very sophisticated machines. This one says door open, so I'm going to open the door right over here. Stainless steel chamber. Very heavy door that locks and cannot be opened during the cycle. Over here we have a door gasket. Stainless steel chamber that has to be cleaned regularly. And down on the bottom on the floor over here, probably won't be able to see with the camera, but down in front over here we have a drain. The drain has to be cleaned daily. Otherwise, if the drain is clogged, you cannot remove condensation from steam there. And if you can't drain the water out of the chamber, you produce wet packages. Wet packages equal unsterile, and the entire sterilization process has to begin in the decontaminant. Can't just stick it back inside and run the sterilization cycle. It has to start from the very beginning. Okay, so drain is cleaned out daily. We clean the chamber with manufacturer-approved products only. But suffice it to say that we do not use anything abrasive. We do not use SOS pads, no scouring pads, no scrubbing powders like Comet or whatever. None of that stuff. Only manufacturer-approved materials. All right. Temperatures in these guys run between 250 and 275. Dynamic air displacement Fahrenheit, which goes from 125 to 135 Celsius. All right. These machines right over here have mechanical indicators built in. You got pressure gauges, you got temperature gauges, and you have timers. All of these have to comply, and together with chemical indicators, biological indicators, and these gauge readings, these guys give us reasonable assurance of sterility. Okay? So as I mentioned before, a biological indicator has to be put down in front next to the drain. Next to the drain would be the last vestiges of air that hasn't been removed. A pocket of air would make it more difficult to sterilize. That's where we put our biological indicator, because if we can sterilize down there by the drain, we can sterilize anywhere in the chamber. That would be the assumption. Okay? Outside, which you can't see outside the chamber, there's a jacket. Jacket keeps the chamber warm because we have the same pressure and temperature in the jacket as we do inside the chamber. That prevents condensation. Another piece of anatomy of the sterilizer is something called the thermostatic trap. Thermostatic trap shuts off, closes off the passageway for air and steam when you reach proper temperature and pressure inside the chamber, so we can start building up steam pressure and temperature inside there. If we look at the packages over here, we can see the chemical indicator tape has turned a color. That particular color indicates that it has been run through the sterilization cycle. This little tag right over here bears a Julian date. Julian date is something that tells us how long it's been since the first day of January. Okay, they keep track of inventory and sterility this way. The sterility of a package is not usually guaranteed by time, though some of them do have an expiration date. Package sterility is event-based. Okay, meaning something happens to a package. What could happen to a package? It could fall. You could carry it in your hands, and you really shouldn't carry it in your hands. Even if you're not going too far, put it on the cart. And the cart has to be very specific. The cart has to have a solid bottom and closed doors, so you don't, while wheels are turning, you're not dragging up anything into the package. All right. So even that has to be special. We have to take that into consideration. What else could happen to a package? Temperature and humidity levels could change in sterile storage area, which is where we're about to go.